All right, let's get right into it. Welcome. Today we're building a rock-solid foundation in statistics. We are going to master the exact mathematical tools you need to unlock and truly understand literally any data set you come across. So let's get started.
We've got a really clear path ahead of us today. We'll start with the truth about averages, then measuring the spread. From there, we're tackling frequency tables, moving on to estimating grouped data, and finally wrapping up with real-world math mastery. We're going to start with simple, everyday numbers and scale all the way up to some complex grouped data challenges.
Section 1. The truth about averages. It's time we move beyond just saying things are somewhere in the middle.
You know, in everyday conversation, saying you're of average height or have average ability, well, it just kind of implies you're somewhere in the middle of the pack. But mathematics? Mathematics demands exactness. The crucial point here is that in math, average isn't just one vague catch-all concept. It actually represents three distinctly calculated, highly specific methods: the mean, the median, and the mode.
Let's break these down really quick. The mode is simply the value that occurs the most often. Easy enough, right? Then there's the median. That's the exact middle value, but only when all your data is arranged in order of size. And finally, the mean. This is what most people are actually thinking of when they say the word average. You find it by adding the total of all data values together and then dividing by the number of values. So if we're looking at a raw list of 15 numbers, finding these three measures means we just arrange them, spot the most frequent, and do a little bit of division.
Moving on to Section 2, measuring the spread. Because honestly, averages don't always tell the whole story.
Here's something that's actually kind of wild. Two completely different sets of data can share the exact same mean and median, but look completely different in reality. To truly understand what data is doing, we have to look at the spread. And the absolute simplest tool in our belt for this, the range. It's just the difference between your absolute largest value and your smallest value.
Actually, before we scale things up, there's a strict methodology you really need to remember. Finding the median of an odd set of numbers is super easy. You just pick the middle one. But if your data set has an even number of values, well, there is no single middle number. You must arrange the scores, locate the middle pair, add them together, and then divide by 2. So for instance, if your middle pair is 5 and 6, your median is exactly 5.5.
All right, Section 3, tackling frequency tables. Let's see how this scales up. Let's see how this builds when we're suddenly dealing with an entire class taking a math test instead of just a simple list of numbers on a page. Picture a frequency chart showing scores out of 10. If we map out the most frequent scores, a visual pattern immediately emerges. We'll see a high concentration of students scoring around 5, 6, and 7. But how do we accurately calculate the mean of all 32 students without writing out some massive, confusing list of 32 individual numbers?
Boom, the frequency table. By translating that visual data into a table format, we unlock the critical frequency times score column. This is basically a shortcut to work smarter, not harder. If 5 students scored a 5, that's 25 marks total for that group. If 6 students scored a 7, that's 42 marks. By adding up that entire right-hand column, we get the total marks obtained by all the students combined, which in this case is 168 marks across 32 students.
And this brilliantly illustrates how we find the mean for larger datasets. By simply dividing those 168 total marks by the 32 students, we get an exact mean score of 5.25. It's clean, it's efficient, and it's completely precise.
Welcome to Section 4, Estimating Grouped Data. I like to call this the boss level. Because what happens when our data isn't exact? What if we only know that test scores fell into broad categories, like 0 to 19 or 20 to 39?
Think about it like this. With raw data, you know the exact positions of all values, so you can make a perfectly precise calculation. But when dealing with grouped data, those exact positions are totally hidden. If 2 students scored between 0 and 19, we have no idea if they scored a 1 and a 2 or an 18 and a 19. They're just buried in that group. Because of this, our mean has to transform from a precise calculation into an estimate. So we need to find a backdoor into the data to solve this, and that backdoor is the mid-interval value. We calculate the exact middle point for each group. For a score range of 0 to 19, the middle point is 9.5. We then just pretend that every single student in that specific group got that exact score of 9.5. It's a calculated compromise that lets us keep moving forward.
Let's see this in action. Say we've got 40 history students. We set up our table, but this time we use our new mid-interval values.
By multiplying the frequency of students in a group by that mid-interval value, we can estimate the total marks. Got 14 students in the 40 to 59 range? Just multiply 14 by the mid-interval of 49.5, and you estimate 693 marks. We do this for the entire dataset, estimating total marks even though we don't know a single student's exact score.
Oh, and real quick, while we're looking at group data, we should also identify the mode, or in this case, the modal class. The modal class is simply the specific group that pops up the most often. Looking at our numbers, the group with the greatest frequency was clearly the 60 to 79 range, which had 16 students.
So, to wrap up our estimate for the mean of those history students, we just add all those estimated frequency times mid-interval totals together and divide by our 40 total students. This gives us our final estimated mean of exactly 57.5.
Section 5. Real-World Math Mastery. Putting the concepts to the test.
Now that you've got the statistical tool belt firmly strapped on, let's see how these exact definitions apply to tricky real-world scenarios. Look at this situation. A class takes a math test. One teacher looks at the results and says, "Great, the average result was 10 out of 10. But another teacher looks at the exact same results and argues, "No way, the average is only 7.5 out of 10. How can they both claim to be calculating the average from the exact same data set?
Well, it totally depends on the tool they used. Teacher A likely noticed a maximum score or maybe lazily used the range, seeing a top score of 10. Meanwhile, Teacher B actually took the time to calculate the exact mathematical mean or median. Whether you're calculating the mass of a new substitute player joining an 11-person team or figuring out how a basketball player's mean points jumped after a few incredible games, the specific mathematical definition you choose literally dictates reality.
So the next time you're out there analyzing numbers in the real world, I want you to ask yourself a critical question. When someone says average, are you looking at the mean, the median, or the mode? And more importantly, what is that specific average hiding about the true spread of the data?